9! How you get this answer wrong? I am a bit disappointed in you since I didn't give you the hints, but it's okay. That's why I'm the great wizard is here. Now, let me show you how to answer this question. You see here, calculate the energy emitted. So, we're going to highlight energy emitted. This is the first thing we need to find. The second one, and wavelength. This is the second thing we need to find. Proceed. When electron in hydrogen atom is transferred from N6 to N2. Now, dear Knight, let me ask you, if you have N6 and N2, obviously you have a change between two energy levels. So how are we going to detect which one is the initial and which one is the second? So now, you see here from N6, this is going to be our initial, this is going to be our final. So as you can see here, I will highlight Rydberg equation. Because the information that we have is by using energy levels. If I ask you right now, can I find the energy emitted using this formula? If your answer is yes, then you're wrong! But if you say no, that is correct. Because we have energy levels here as I stated earlier. So now, let me fix my here. Let me continue. By using this formula, I'm going to write it out. Energy difference equals to this is one thing that I gave you earlier, right? The Rydberg equation. Rydberg constant. Come here, guys. As you can see here, we have two Rydberg constants. I already told you in the hints earlier. If you get this wrong, you're going to die. So we see here we have two Rydberg constants. The first one is 2.18 exponent -18 joules, while the other one is 1.097 exponent 7 Newton -1. Let me ask you, dear Knight, which one should we use, the first one or the second one? For energy emitted. If your answer is A, you're correct. If your answer is 2, you're wrong. Because I said earlier, this is defined wavelength. This is defined energy. Let's continue. So obviously we choose the first one, which is 2.18 times 10 18 joules. I need to know one more thing, right? As you would know, in the exams, we're only given our constants. We're not given the equation. So you have to memorize all the equations. But don't worry, dear Knight, with a lot of hard work and dedication, I'm sure you can do it. Continue back to our substitution. 1 is going to negative 18 joule. Now 9, let's put it here. 1 over 2 minus 1 over 2. Now, this area we need to memorize this, correct? This is also consistent. You need to memorize this because let's say in the scheme of answer, even if they didn't highlight this, you need to know because it is for you to use when substituting. So now, let's see. We have the condition here, which is N1 is smaller than N2. And now, dear Knight, you see here we have two spaces that we need to fill with the energy levels. So now, you see here, energy level 1, energy level 2. How are we supposed to know which one? That's why, as I said earlier, when you memorize the equation, this is also insistent. Even, let's say, the scheme of answers didn't insist this one, but it's incredibly important for you to know when substituting in the equation. So now, we have N1 and N2. The condition here is that N2 needs to be bigger than N1. So let me ask you, Knight, again, this is the third time I'm asking you. N2 needs to be bigger. So which one is supposed to be our N2? Is it this one or this one? If your answer is this one, you're correct. But if your answer is this one, you're dead. So now, let's continue. So you see here, our N2 is 6 and our N1 is 2. Let's substitute it here. 6 to the power of 2 minus 1 over 2 to the power of 2. Close it. Now, you can just change it. You can just insert it in the calculator and get your answer. The answer would be 4.844 exponent negative 19. Again, don't forget your units since you're using this rapid constant. See here, you got it here, night. But again, it's incredibly important for you to bring your amazing wizard form with you to calculate the calculator or your traditional calculator to the exam. So please remember that. Now, moving on. The next thing we need to find is our wavelength. So now, let's go back. We have, let me answer you, right? Is this our wavelength? Yes or no? If your answer is yes, you're correct. If there is no, grrr. So, you see here, we can use this formula. Or, as I said earlier, since you need to memorize all the formula, you also need to know that one of the formulas that we need to memorize is 1 over lambda, or 1 over wavelength, will equal to rapid constant in bracket 1 over n initial to the power of 2 minus 1 over n initial, n final to the power of 2. So, you can see here is substitution. I'm going to use my wizard power and bring it over here. So now, let's continue. We need to find a wavelength. 1 over lambda will equal to, let me ask you again, which one should we use? Is it this one or this one? The answer is this one, because what is the unit for lambda? It's n. You see here both is over n over n. So if we evaluate and then we do our basic algebra, we're able to get n. You got it then, right? Let's continue. So now 1 over lambda will equal to rapid constant 1.0977 times 10 to the power of 7 in bracket 1 over, you can see here which one is our n1 or n2. You can see here that our n1 is supposed to be 2, our n2 is 6. Why? Because as I stated earlier, this is our ground state and this is our excited state. So now let's continue. Come here, dear knight. This is supposed to be 2 to the power of 2 minus 1 over 6 to the power of 2. And now, if you press your trusty calculator, you will get the answer equals to 4.103 exponent negative 7 meter. But oh wait, we also have an alternative way to answer this question. Instead of using this, we can also use, come here, this. I stated earlier. Why? Because we have lambda. And this is our constant. And let me find this, dear knight. The answer is yes. Let's find it here. So now, let us continue. Energy difference equals to what is our constant? Again, dear knight, don't forget the constants are provided to you in the exams. So the constant here would be 6.6256 exponent negative 34 times speed of light in vacuum, which is 3.0 exponent 8 over our lambda, which is going to 5. So now, can we already substitute this one? Yes, because it's earlier. Ready for this? We're going to erase this and substitute it with 4.844 exponent. And oh, I just noticed this. I'm sorry, dear guy. Okay, exponent negative 19. Now, using all the knowledge you have gathered during your quest into finding your journey into being the greatest of all, you already know we have to use our algebra. So just use a simple switcheroo here, and you will get the answer is 4.103 exponent negative 7 Peter, this it will be the same. Either formula you use, you get the same answer. And that's how you answer it, dear knight.